Thanks for taking the time. I'm going to be presenting about WalletConnect. I hope that some of you have heard of it from the Ethereum community, at least. And I hope that some of you didn't heard of it and you're learning from it for the first time today. WalletConnect exists for about 2 years or so, and it's a protocol for connecting dApps to wallets. But the version 1 has been in production for that entire time, and today we're going to talk about how WalletConnect has evolved into its version 2. Because now, with version 2, we're going to go to Interchain and beyond. So the whole point of the version 2 protocol is that it will no longer be just a project that facilitates connecting dApps to wallets on Ethereum, but it also goes to a multi-chain universe where we can actually support multiple wallets. To start, I would like to introduce myself. I'm Pedro Gomes. I'm the founder of WalletConnect Labs. You might know me on Twitter as Pedro UID. And I ordered WalletConnect protocol when I first wanted to connect my mobile wallet, and there was no other solution at the time other than using MetaMask. And since then, I've been working on trying to facilitate mobile experience for wallets, and that's where WalletConnect came in. And I think that now has been the time where multi-chain universe has really caught up, and we really need to expand beyond just a single chain, and applications have to evolve to that. So that's what's new with WalletConnect. That's it. We're introducing multi-chain support, something that has been asked for a long time. We're getting started with obviously supporting the existing tooling with Ethereum, and then we're rolling out different tooling for Cosmos and Polkadot and other chains in the future. But for those who don't know what WalletConnect is, I would like to explain how it works, and I would also like to go into detail of how WalletConnect 2.0 works specifically. To summarize it very simply, it's a secure remote signing protocol. If you were in a blockchain application, mostly on the browser, you would need to connect your wallet to sign messages. And we introduced this pattern through a QR code that actually allows you to sync your mobile wallet to the browser. And the way we started it was that it was exclusively for mobile to desktop. Well, we have now actually expanded it to also mobile to mobile. So you will have your mobile browser also connecting to a mobile wallet to actually sign messages securely. And how do we actually sign these messages securely? Basically, you could break down WalletConnect as an end-to-end encrypted JSON RPC relayer. There is an application where you actually going to interface on the browser, and then there's a wallet, which most of the times would live on the mobile. And you would need this message to actually access securely to the wallet. And to make the user experience the best, we didn't want to have QR code scanning back and forth as you have with air-gap wallets. So we use what we call a relayer, where you actually pass these payloads along without compromising the privacy of these payloads. The way we do this is that the wallet will capture the out-of-band data, which is a simple URI. We'll have the sufficient data to actually sync these two devices together and actually encrypt the payloads that are going to be relayed. Currently, this relay server is a WebSocket connection that you will publish and subscribe to certain topics. But with WalletConnect 2.0, we actually expand this to be completely agnostic, and not only basing on a WebSocket connection, but it could also use a decentralized messaging protocol like Waku, or for example, you could even use Onion protocol to actually publish and subscribe. So the way we started was that we need to sign a message from the wallet, and this uses JSON RPC. The reason we use JSON RPC is because it makes it very isomorphic to actually pass these payloads along. Structuring around REST, kind of hard-coded it into a client-server architecture. And with JSON RPC, we're able to proxy this along a whole path from an application to a JSON RPC provider to a relay network into a wallet, and then sign the request and securely send it back to the application. We use some cryptographic primitives like 25519 to generate the shared key derivation. And we use AES 256, HMAC 256, and basically have an authenticating encryption scheme where the two clients can encrypt the payloads, and they are completely private within whatever relay network you use. Currently in the WebSocket bridge, but you could actually relay whatever network you want. Use libp2p, for example. So the main changes with the WalletConnect protocol that come from version 1 to version 2 include that the API is no longer hard-coded to be Ethereum only or EVM, so only Ethereum chains would be supported. It's now completely agnostic to any chain. And when I say completely agnostic, it's not just introducing Cosmos and Polkadot support. Those are just the first chains we're going to be supporting with the existing tooling that we have, but actually it will be agnostic to any blockchain to use WalletConnect to connect an application in a wallet. The WebSocket will not be the only way of relaying payloads anymore. It's completely agnostic as long as it follows in a specific interface of public subscribe, which is very similar, completely almost the same, basically, of the libp2p public subscribe API. We also introduced something that was somewhat of a hindrance in some edge cases where the messages were delivered very optimistically. So there was this assumption that the other client, once received the message, there was no acknowledgement of this message. So now we actually have a guaranteed message delivery mechanism where we actually try to ensure with retrials that the actual client receives these messages. Session lifetime. Something that was kind of good for adoption of the version 1, but actually was starting to create some inconsistencies across wallets, where some wallets would actually expire sessions too soon, some wallets would not have sessions in parallel. So now we actually have a very fixed session lifetime where wallets need to ensure this connection until expired, unless the user specifically rejects the session to not expire at the specific time. And most importantly, we have unlimited sessions per connection. There's no longer this concept of having to have a unique connection per session. And how would this actually work? I would like to take back to the actual slide where we actually have the relay, and this out-of-band data would actually be specific to a single session. So whenever you actually wanted to initiate with another app, even though you're using the same browser, there should be no concerns about using the actual encrypted keys to actually relay the payloads across the PubSub. And now with WalletConnect 2.0, that is possible. So you would be able to actually share this out-of-band data once to actually connect a wallet to a browser and just initiate as many sessions as you want with different permissions and different hosts. And how do we actually achieve the chain agnostic capabilities on WalletConnect 2.0? It's through standards. There's nothing more important to WalletConnect than introducing new standards. We've participated a lot in Ethereum improvement proposals, and now we're actually taking a step further into this organization that we participated at the inception, called the Chain Agnostic Improvement Proposals, that actually bring standards across chains, not just to Ethereum, Cosmos, and Polkadot, but beyond, to actually create identifiers, for example, for blockchains, where we actually have a agnostic chain ID, or we have account identifiers, which are agnostic, and we also introduce some APIs for JSON RPC communication that are also agnostic and actually provide this broad scope of connection between an application and a wallet without prior knowledge of whether they are compatible or not. So that's what I would like to dive in, which is what WalletConnect really brings onto the table, is with these new CAIPs. So the first one, CAIP2, it kind of tries to bring this normalization between all the chains that have different ways of resolving an ID. For example, on the Bitcoin mainnet, you might have the BIP 122, where you actually get the Genesis hash, and you're actually able to detect which chain you're connected to. On Ethereum, we have an integer. On Cosmos SDK chains, you actually are able to identify this from the node information, where you actually have an actual string. On Polkadot, we actually introduced our own schema that actually is very similar to what Bitcoin did, where you actually return half of the genesis hash. And with this, we're actually able to then construct better standards. And so from the blockchain identifiers, we actually go on into the account identifiers. And with account identifiers, it looks very similar to how you would construct an email. So if you take the chain ID and you append it and you do @ with the address, you're actually able to have a very contextual identifier for the address. In the case of Cosmos, actually, it's one of the best ways of actually identifying addresses because they're actually prefixed with the Cosmos SDK. But even then, you wouldn't be able to tell which chain this actual address would be. It could be a chain that actually uses the Cosmos SDK by default and just uses Cosmos. But you actually have that pre-appended that suffix of the chain ID. And the same thing happens with Ethereum and with Polkadot and Bitcoin. And these are some of the identifiers that we've started building on, but it actually would work for any chain that we would like to expand. On the JSON RPC side, something that was very important was to actually have this session permissions being agreed upon a session initiation. And the first thing that you ask is what chains you would like to connect to from the application standpoint. So you could have, for example, an atomic swap application where you actually would like to swap between two Cosmos chains, for example. So you would need that connection from the wallet to sign messages from both chains. So you have an array where you list the chain IDs using the CIP2 chain IDs that you wanted to target. And from that, you also introduce the concept of like a scope of JSON RPC methods, which you also include as a list with a string array, where you actually define, these are the minimum JSON RPC methods that I'm gonna need from you to actually sign messages and be able to interface with this wallet. And this provides an ability of having multiple wallets supporting WalletConnect without breaking the compatibility in terms of being connected to a specific API, because the application is explicitly requesting this, and the wallet is consenting that the compatibility is met up front so that the session can be connected right away. And once the connection is actually approved, both from the wallet that it verifies the compatibility and from the user that wants to connect to this application, we actually return a set of accounts that match the scope that it was requested from the chains. And then you're actually able to interface with the provider request standard, where you request a target chain which you want to target this JSON RPC method. And for that, you use the CIP chain ID as a string, and then you append the request method and params as a second argument. This can then construct what we're still working on, or what we call a multi-chain JavaScript provider, where you can do multi-chain applications with a consistent API that can connect to any wallets that would proxy to any nodes, and would have a method to enable the provider by specifying its chains and methods, and then make requests targeting those chain IDs and methods. So this has the behavior where you would initiate a session with a wallet using the handshake that we specified before, and then these requests would have to meet the requirements of the chain ID being within the scope agreed upon enable, and then the request method to be within the scope of methods. And this makes us what we think is the best pattern to have a chain agnostic interface between blockchain applications and wallets. And demo time. I would really love to have like a demo for you guys. I've been working really hard with the CAIPs to actually present how this would actually work. WalletConnect 2.0 is now in alpha stage, and it's published on NPM, and it's working really well. And it has passed a lot of unit testing internally, but we haven't gotten to a point where we actually have like an application that it will more visibly to implement these multi-chain providers within the multi-chain application, but it's getting there. It's getting really there. And I'm really excited about this because it's really breaking that pattern of a single chain application, and actually not only being chain agnostic, but also multi-chain, where two chains are actually connected within an application context. We will have more questions, but if you are interested in participating in this, I would like you to visit the documentation for WalletConnect, our GitHub, Telegram, and Discord. And we're always welcome for contributions, and feedback is always the best part that we get from these interactions. If you're new to WalletConnect, I definitely recommend you try our demos for V1. And the V2 documentation is also present under the alpha stage, but you will be able to read more about this. So the first question I can see from RV, it explains what is the business model of WalletConnect. WalletConnect as a company is a consulting company that builds these protocols and builds support for these interactions between different wallets and chains for different clients that we have, but also we build these protocols, these open source protocols, through grants. The first protocol, the V1, was funded by the Ethereum Foundation and also Consensus, and now the version 2 protocol was actually funded by Interchain Foundation and Web3 Foundation to actually expand this protocol to go beyond Ethereum. And this has actually been very successful because we've had a lot of contributions from different projects, especially on the CAIP standards, where a lot of people have actually met these problems and have been able to actually contribute to producing better identifiers. The business model of WalletConnect as a protocol, there isn't one, because this protocol is shared between 40 wallets currently and over 80 or 90 decentralized applications as far as I know. And it's open for everyone to contribute, and we have more than 25 contributors on GitHub. And we hope to one day see more business models be built on top, especially on the relayer side. We have a very comprehensive relayer infrastructure to actually ensure good user experience, and we hope to actually bring new features in the future. I would love to see if anyone else has any more questions regarding architecture. Especially, a lot of people usually ask me, what is the motivation between focusing so much on JSON RPC, especially that JSON RPC was mostly dedicated for client-server architecture. And in my opinion, the JSON RPC is not necessarily the best, but is the most flexible structure for remote procedure calls, because it's compatible with both browsers and also mobile wallets in different environments. While I would like to see a future where we actually evolve from JSON RPC to gRPC. I don't think we're at that stage, but I feel like it is possible to define APIs in gRPC and convert them into JSON RPC to make it browser compatible. Any more questions?
Awesome. Do you have any final thoughts, any last words, or are you done with your presentation?
Yeah, I would like for more people to explore these identifiers. I feel like, as I said, these solve interoperability problems, not just for the use case of WalletConnect, but also for other projects. For example, one of the most involved projects also at the inception was StarName, that actually provided naming solutions for multiple chains and used these blockchain and account identifiers to actually have naming resolutions to be chain agnostic. So Ryan is asking, have any strategy or thoughts to defend against new government censorships to try and force KYC on personal wallets? If you think about it, WalletConnect at this stage with WalletConnect 2.0, since it has brought transport agnosticism through the publish-subscribe interface, it actually provides a good defense to censorship resistance. The WebSocket publish and subscribe relayer is definitely the best solution in terms of latency, but it definitely introduces censorship problems where you could actually have to target certain geographical regions to actually protect users that are not KYC, or maybe whitelist some wallets because the relay infrastructure is controlled by the governments. But if you are using a decentralized messaging protocol like Waku, where you can actually broadcast through gossip, you don't actually need to use WalletConnect through centralized services, even though it might introduce some latency into your connections. So I think that this actually provides a good mechanism to prevent the user experience to deteriorate with privacy concerns, but still maintain some privacy. What is the main programming language used by WalletConnect? Why was that language chosen? Like I said, WalletConnect's main use case is to connect to browsers. There is a lot of mechanisms where you can actually connect native apps together very easily, but for browsers it's actually very limited. So obviously the main programming languages was JavaScript, and it has been since the day one, mostly TypeScript. I don't think we've ever published anything in JavaScript in the last 3 years of its protocol. And it has been very successful, although it did come with some lag between the Swift and Kotlin libraries, which we're trying to solve. And we're actually considering writing a Rust library to actually deploy mobile libraries to actually have a more consistency between the two code bases. Great. Thanks a lot for those questions, RV and Ryan. Those great questions. I love them. If no one else has questions, I would like to definitely ask everyone to visit our website and other documents. There's multiple applications right now in production using WalletConnect V1. And WalletConnect V2 already has alpha packages available on NPM and documentation regarding how more in detail the protocol actually works in terms of multi-session connections and in terms of the chain agnostic APIs, as I've described. And I really hope that we will start seeing these rolling out into production very soon.
Awesome. Thank you so much. So what we're going to do is take a short 7-minute break, and then we will transition to our next talk. Thanks so much. This was great.
Thank you. Thanks for inviting me.